participating in the reactions, these atoms cannot be created or destroyed in the course of a chemical reaction. So basically, the number of atoms that are participating at any time in the chemical reaction remain the same. What changes is the identity of those atoms, how they are found, in what state they are found, if they are bonded or if they are solitary or separate, that changes. The chemistry changes, but the number, the mass, how much, how many are there, that never changes. The reactants, that is the LHS, and the products on the RHS will always have the same number of atoms. On LHS and RHS. So that brings me to why we need to balance our chemical equations. Well, that is because of this law of conservation of mass, that tells us that all reactions are balanced. That means both on the reactant side as well as on the product side, the atoms will remain the same, and hence we need to balance these. Let us first look at this equation. It says magnesium plus oxygen gives magnesium oxide. We need to ascertain how many number of atoms there are. The number of atoms of each element are same on the reactant side and the product side. For that, I'm going to make a small table like so. So here I'm going to write magnesium and oxygen, and on top I'm going to write reactant and product. And let us see how many atoms we have on both sides. So on the reactant side, I have one atom of magnesium, and on the product side, I have one atom of magnesium also. Then let us look at oxygen here. Oxygen, I have two atoms. This is an oxygen molecule, and here the 2 indicates the number of atoms of oxygen. So on the reactant side, we have 2 atoms of oxygen. And if you see on the product side, how many atoms are there? Well, there is nothing written over here, and nothing means 1. So we can see that there is a disparity between the number of atoms on the reactant side and on the product side in case of oxygen. This means that the reaction here is not balanced. This is not balanced, and this kind of equation is called as a skeletal equation. And to be diligent chemist, we need to dot our I's and cross our T's. So we need to balance our chemical equations. So we'll take a look at this equation itself, and let's try to balance this. First, I'm going to make boxes around each of the molecule that is there on the reactant side as well as the product side. And what this will do, that it will prevent me from making any changes inside these boxes. You can take this as rule number 1, make a box. And you have to remember to not make any changes inside the box. The changes can only occur on the outside of boxes. That means that the coefficients that are there that will be balanced will be added on the outside of boxes, not on the inside. As it is apparent from what we have already done, we are going to move to the step 2, which is, and in the balance chart, what we are going to do is, we are going to list out all of the elements that are participating in the reaction, and we're going to count the number of atoms of that element on the reactant side as well as on the product side. So here we can see that I have listed 2 elements because there are only 2 elements that are participating in this reaction, that is magnesium and oxygen. On the reactant side, we have 1 atom of magnesium, and on the product side as well, we have 1. And oxygen, we have 2 on the reactant side and 1 on the product side. We can write this as step 3, that is to find the element with highest number of atoms and balance it. So the third step would be to determine which element has the most number of atoms, and then we target that and we begin our balancing from there. We can clearly see that oxygen here has the most number of atoms. So we're going to start with oxygen. And what we are going to do to balance it essentially is to look at the reactant side as well as on the product side. On the reactant side, we have 2 atoms of oxygen, and on the product side we have one. So we want to make both the sides equal. So we're going to take the LCM of the reactant and the product so that both of these become equal. Well, it is plenty clear that to make this equal, we can simply multiply the product side by 2. And here, if we multiply oxygen with 2 on the product side, we can then make the changes in this equation accordingly. I am to multiply the product side with 2. That means everything on the product side, since it is one molecule, the entirety of it will get multiplied with 2. So I am going to write this equation again and make the changes whatever I've made here. Since I've multiplied it by 2, I'm going to write it as it is in front of this molecule. So why am I not writing it here? I told you guys that to remember that nothing changes within these boxes. So whatever multiplication that you're going to do, you're going to do it in this form. So here I've multiplied it by 2. We can see that this changes things. Well, this was my balance chart. And let's have a look at how things have changed after I've made this addition of 2 in front of MgO. This 2 that I put here to balance oxygen not only has increased the number of atoms of oxygen, but now it has also increased the number of atoms of magnesium. So let us revise how many number of atoms are there of each element once again. This is the reactant side and this is the product side. So we can see that on the right hand side or on the reactant side, the number of atoms of magnesium remain 1. So this is going to be the same. Then on the product side, however, we have a 2 in front of this molecule now. That means 2 not only gets multiplied to oxygen, it also gets multiplied to magnesium. What does that make the magnesium on the product side? How many number of atoms are there of magnesium? Now there are 2 magnesium atoms. So I'm going to revise this here and I'm going to write 2. Once again, while I revise my chart, I see that now oxygen is balanced. Kudos to us. But the magnesium now has changed and there is an imbalance in the number of atoms of magnesium on the reactant side and the product side. On the product side, I have 2 magnesium atoms and on the reactant side, I have 1. So how should I make them equal? I'll take the LCM once again, and when I take the LCM, I see that it is going to be 2. So to make both the reactant and the product 2, I have to multiply the reactant side by 2. So I will multiply the magnesium on the reactant side, which is this single atom here, by 2. So I'll add 2 in front of magnesium. And now once again, we will tally all the number of atoms on the reactant as well as on the product side to see if our equation is now balanced. On the reactant side, how many magnesiums are there? Let us count. So we have 2 magnesiums on the reactant side, and on the product side we have 1 magnesium here, but it will be multiplied by this 2 coefficient on the outside, and we have 2 atoms of magnesium on the product side as well. So that means magnesium is balanced. Then we move on to oxygen, and oxygen here, as we can see, has 2 atoms. So 2 on the reactant side, and how many on the product side? We have 1 atom here, nothing means 1, and this 1 will get multiplied, of course, to the coefficient outside. In total, it will become 2 atoms of oxygen as well. That means the reactant and the product side of oxygen is also balanced. This means now this equation is completely balanced. We're going to then write neatly what our final equation is. So 2 magnesium plus oxygen gives 2 MgO. This is our final balanced equation. So here I have for you another example, and this is a easy type example. So I think if you remember all the steps, one of which I have done for you here, we can do this equation together. So first step was making the boxes outside of the molecules and atoms in the equation so that we are not tempted to edit anything inside of these boxes. Anything inside should remain as it is, and the coefficients will be added outside of these boxes. Then comes the balancing chart, wherein we are going to write down all of the elements in the equation, which are phosphorus and oxygen in this case. And then we're going to write out all the elements and their respective atoms on the reactant side and on the product side. On the reactant side, we have four phosphorus atoms and we have two on the product side, and oxygen, we have two oxygen atoms on the reactant side, and on the product side, however, we have three atoms. So this gives us a good beginning point to balance our equations. And if you remember the steps correctly, the third step was to identify the element with the highest number of atoms. So here, that is phosphorus on the reactant side. On the product side, we have 2, and on the reactant side, we have 4. Taking the LCM of 2 and 4, we know that it is 4. That means that we are going to have to multiply the phosphorus on the product side with 2 to make it 4. So let us edit this equation. If I write this equation again with the changes that I have made on the product side, because I have multiplied 2 on the product side and this is a molecule, I have to write 2 in front of the whole molecule, and I am not going to forget to put these boxes so that I change nothing inside. If I revise my balancing chart again, here on the product side, now we have 4 phosphorus atoms. But then again, this changes the whole equation. So let us again try to count the number of atoms of each element. Phosphorus on the reactant side, we have 4 atoms, and on the product side, you can see that we have P2, which is going to be multiplied by this 2 outside. So now the total number of phosphorus atoms is 4. That means that phosphorus is balanced. Let's move on to oxygen now. Oxygen on the reactant side, we have 2 atoms. And here on the product side, inside the box, we have 3. But everything on the outside gets multiplied by everything on the inside. That means total number of atoms of oxygen are now 6. So we're going to make this little correction here. We're going to write 6 on the product side. So how should I go about balancing oxygen now that the reactant side has 2 atoms and product side has 6 atoms? Once again, we are going to follow the same routine, taking the LCM. And what will be the LCM of 2 and 6? It is 6. Product side will remain the same. The changes will be made on the reactant side. And what we are going to do to make 2 into 6, we're going to multiply it by 3. That means there are going to be some more changes in this equation. So on the reactant side, we have oxygen as a single atom, and we're going to multiply it by 3 here. So we're going to have to look at all the number of atoms of elements once again to see if now our equation is balanced. So let us look at it once again. Number of atoms of phosphorus on the reactant side are 4. Number of atoms on the product side of phosphorus are 2 into 2, 4. Oxygen we have on the reactant side, 2 atoms of oxygen inside the box multiplied by 3 gives us 6 atoms of oxygen on the reactant side and 6 atoms on the product side as well. That means oxygen is also balanced. So now we can write our final equation after confirming that everything is balanced. We have P4 plus 3O2 gives 2P2O3. This is our balanced equation, guys. And then we can try out other type of equations which have multiple number of elements. So here we have 3 elements. Previously we were doing 2 elements. Let us begin by the first step is already done. That was sketching out these boxes outside of the elements. And now we can start with our balancing chart, which will require us to list down all of the elements here. So firstly, On the reactant side, the number of atoms of aluminium are 1. I can only see 1. On the product side also we have 1. Coming to hydrogen, we have 1 atom of hydrogen on the reactant side, and we have 2 on the product side. Chlorine, we have 1 on the reactant side and 3 on the product side. Third step was to identify the element with the highest number of atoms. And in this case, that is chlorine. So we're going to start with chlorine. We will have to take the LCM of 1 and 3. That is 3. Product side is already 3. To make the reactant side 3, we're going to multiply the reactant side with 3. We're going to rewrite the equation with the changes that we have made. So then I'm going to write 3 in front of the chlorine on the reactant side. This chlorine is bonded to H in form of a molecule. So I'm going to write 3 here. You might be tempted to write 3 here, but that will be a wrong move. Then we're going to revise everything once again and see how the tally has done so far. So again, the number of aluminium atoms remains the same. Hydrogen on the other side, on the reactant side, the number of hydrogen has turned 3. It was 1 and now it has turned 3. How? Because 3 outside of the box will get multiplied to the hydrogen on the inside. So here the tally becomes 3. So we have 3 hydrogens, and then on the product side we have 2, and chlorine is balanced on the reactant as well as on the product side. So aluminium is also balanced till now, but we need to have a look at hydrogen. So on the reactant side, we have 3 hydrogen atoms, and on the product side, we have 2 hydrogen atoms. Once again, we're going to take out our weapon of LCM, and we're going to take the LCM of the atoms on the reactant and on the product side. Taking the LCM of 3 and 2, it comes out to be 6. So we have to make 6 on the reactant as well as on the product side. How do we do that? To make 6 on the reactant side, we have to multiply 3 into 2, right? That makes 6. And on the product side, we have to multiply the 2 with 3, and that makes 6 on the product side as well. Now we're going to rewrite our equation as we have made the changes in this equation. So we have multiplied the H on the reactant side with 2. On the reactant side, instead of the 3 here, we are going to write 6. And on the product side of H, which is a molecule of H2, we are going to write 3. Once again, we'll review the equation to see if all the atoms are balanced. So let us begin from aluminium. Aluminium on the reactant side, we have a 1 atom and 1 atom here. Aluminium is balanced. Hydrogen, we have 6 atoms of hydrogen on the reactant side, and on the product side, we have 2 inside the box and 3 outside. That makes it 6 on the product side as well. That means hydrogen is now balanced. Chlorine, we have 6 on the reactant side, and we have 3 on the product side. Now this makes another disparity in our equation. We have 6 atoms of chlorine here, and we have 3 atoms of chlorine on the product side. So how do we balance this? First of all, we're going to rewrite our equation here. We have 6 atoms on the reactant side and 3 on the product side. So now we have to balance the chlorines. To balance the chlorines, once again, we will take the LCM of the reactant and the product and the atoms. Here we have 6 atoms of chlorine on the reactant side, and on the product side we have 3. So LCM of 6 and 3 is 6 itself. So we don't need to do anything to the reactant side. But to make the product side into 6, we need to multiply it by 2. That means we will multiply here in this equation. I'm going to make the change right here. I'm going to multiply on the product side with 2 to make the chlorine into 6. So now once again we will go through the same process of reviewing the equation again to see if all the atoms are balanced. Here I'll start with aluminium once again. So on the reactant side we have one atom of aluminium, but here because we multiplied aluminium chloride atom with 2 to make the change once again, this is a little cumbersome, but stay with me guys. If you get through this, you will be able to solve most equations. So here on the aluminium side, we're going to write 2. So once again, I have an imbalance in my balance chart here. So I have two atoms on the product side of aluminium and one on the reactant side. I will take once again the LCM of 1 and 2, that is 2 itself, and we have 2 on the product side. To make the reactant side 2, I'm going to multiply it by 2. Here, fortunately, I have the aluminium atom as a single atom solitary, so I'm going to multiply it by 2 here, and that will balance my equation finally. So we can check that aluminium atoms on the right hand side and on the left hand side, the atoms are the same, that are 2 both sides. The H atom on the reactant side as well as on the product side are also same, as well as the chlorine atoms on the reactant and the product side. So once again, I'm going to write now the final balanced equation as 2Al plus 6HCl gives 3H2 plus 2AlCl3. This is my final balanced equation. Thank you all. I hope you understood today's lesson. For any further details or any queries, you can contact me on this channel, and please do like and subscribe. You can also leave suggestions of videos you want to watch. Thank you. Till next time.